Assalamualaikum to Doctor. I am from Group 70. Our group want to present about the hazard identification, risk assessment and risk control, which is at the Faculty of Electrical Engineering and Technology FKTE at the Blue Building. Before I go to the introduction, I want to intro my group members. I'm Muhammad Nur Aiman, then Muhammad SEPERI, and then the second is Muhammad IRHAM RUSYAIDI bin ROSLI, and then Muhammad Daniel bin AZMAN, then KHAIRULZAMAN EZRIQ bin KHAIRULZAMAN, and then the last is SALEM. For introduction, occupational safety and health is the important to ensure a safety and healthy workplace, which is in the nation. Workplace safety is guided by the Occupational Safety and Health Act 1994, which is the OSHA 1994. Hazard identification, risk assessment and risk control is the method used to identify hazard, assess risk and apply control measures. The implementation of the HIRARC help prevent accident, improve safety awareness and create a safe working environment. And then for the case study area, the case study area included at the Faculty of Electrical Engineering and Technology, which is at the FKTE Blue Building, which is the use for teaching, research and practical engineering activity. The building contains various laboratories and workshop equipped with electrical and electronic equipment such as motor, transformer, oscilloscope and soldering station. This facility are supervised by lecturer, engineer and the technician to ensure safety operation. And then go to the hazard classification. Have the three. First is high hazard, the second is medium hazard, and then the low hazard. For the high hazard, which for example like motor and generator operation, and then the second is high voltage experiment, and then the last is electrical panel and switchgear activity. And then for the medium hazard, we have soldering, and then use testing equipment and power tools. And then the last is the low hazard, which is for example computer simulation and classroom learning.
For the first hazard, improper storage of hazardous chemicals. Chemicals stored in the laboratory may be toxic, flammable, or corrosive if continuously or damaged or stored incorrectly. They can cause chemical spill, toxic fume, fire, or injury to laboratory users. Based on this risk assessment table, the level of risk for this hazard is in medium. For the risk control, first, throw away expired, unused, or unneeded chemical, because having fewer chemicals in the lab means less chance of leak, accident, or bad chemical reaction. Then, treat highly dangerous, toxic, or flammable chemicals or safer alternatives that do the same job. It lowers the risk for everyone, but you must check the new chemical first to make sure it doesn't bring new dangers. Then, use ventilated storage cabinet to stop harmful fume from building up. Use filter to catch leak before they spread on the floor. It physically blocks or separates workers from the danger. For the second hazard, exposure to toxic chemical vapors from fume hood operation. A fume hood is built to suck away dangerous vapors, gases, and dirty air created during lab work. You can be exposed to dangerous chemical if the ventilation system breaks or malfunctions. The sliding glass window is used incorrectly. For the risk control, completely remove highly toxic chemical from the lab if they are absolutely necessary. If you don't use the dangerous chemical, you completely remove the danger. Then, swap out a highly dangerous chemical for a safer, less toxic one. Lower the chance of breathing in bad vapors, but make sure the new chemical doesn't create new problem or ruin the experiment. Next, use equipment like a fume hood to trap and clear away bad air before it reaches you. Inspect, fix, and test the fume hood regularly so the airflow stays strong.
Hazard 3 is an exposed electrical wire located near the electrical service room. The wire is uncovered and sticking out from the wall without proper protection. If someone accidentally touches the wire, it may cause cuts, minor injuries, or even electrical shock. If the wire is live, based on the risk assessment, the likelihood is 3 and the severity is 3, given a risk score of 9, which is classified as a medium risk. To control this hazard, several actions can be taken. First, elimination by removing the wire completely if it's not longer required. Second, substitution by replacing the damaged wire with a safer installed wire. Third, engineering controls by inserting a conduit, protective cover, or junction box to prevent direct contact with the wire. These measures can significantly reduce the risk of injury and electrical accidents. Hazard 6 is an unprotected window opening located near the staircase. The opening does not have any grill, guardrail, or safety barrier. If a person loses balance while using the stairs, there is a possibility of falling through the opening, which may result in serious injuries. According to the risk assessment, the likelihood is 2 and the severity is 4, resulting in risk score of 8, which is also classified as a medium risk. The first control method is elimination by permanently closing the opening if it's not needed. The second method is substitution by replacing the open design with a safer window structure. Finally, engineering controls such as installing safety grills, guardrails, or protective barriers should be implemented around the opening. These controls will help prevent falls and improve the safety of building users. In conclusion, the identified hazards are classified as medium risks. By applying suitable control measures based on the hierarchy of controls, the risks can be reduced and safer environment can be provided for students, staff, and visitors. That's all from me. Thank you.
Next is hazard 5. Expose electrical wire near the electrical service room. This hazard is associated with the use of soldering iron in the laboratory. Since the soldering iron operate at the very high temperature, users are exposed to the risk of burn injuries through accidental contact with the hot tips. Based on our HIRARC assessment, the likelihood and severity are both rated as 3, resulting in a risk score of 9, which indicate a medium level of risk. To control this hazard, engineering controls such as regular equipment inspection and maintenance should be implemented. Administrative control include safety training and warning signage, where appropriate PPE such as safety glass and closed-toe shoes should always be worn to minimize injury risk.
I'll continue the next part, discussion. The FKTE Buildings Hierarchy Safety System assists employees and students in identifying and addressing hazards such as hot soldering irons, unmaintained stairs, and exposed wire before disaster occur. Resolving these issues keeps the lab compliant with official OSHA safety regulations while shielding people from horrific burns, cuts, electric shocks, and fall. Additionally, effectively managing this risk helps the lab operate more sustainability by reducing unnecessary electronic waste and preventing lab accidents and equipment damage. Using routine inspection, safety training, and clear guidelines allows lab users to catch risks early, which cuts down on the cost of accidents and broken tools. Learning these safety habits early helps university students build a strong sense of professional responsibility. Ultimately, this study shows that organized hazard control creates a safer learning environment today while preparing future engineers to run safer, more efficient workplace in the community tomorrow. So the conclusion of this case study that we can give, there are 3 conclusions. The first one is identify and prioritize risk. The study successfully evaluated UNIMAP lab to show exactly which safety issues need immediate fix and which are less urgent. Number 2, propose practical solutions. It creates a realistic list of safety steps that follow official rules to help eliminate dangers and make the workshop much safer. And number 3, provide real-world experience. The project gives students a great opportunity to practice teamwork and understand the true importance of safety from a professional engineering perspective rather than just reading a textbook. So that's all from us. Thank you very much.